This is the assistive alert system by Visionary.
So these are our A and T sketches. Now we got concepts going from headbands to leg exoskeleton to armband to glasses. We got a wide range of things that we addressed, and we to take certain aspects of each sketch, try to put them together, find the best solution for our device.
Which led to the decision matrix, which where we combined all the sketches and different ideas we had, and we focused mainly on the position of the sensors and other devices, the efficiency of the overall product, and the weight distribution, so it did not inconvenience the consumer. And for the revised specifications, mainly what we wanted to focus on was the use of glasses, a fanny pack to hold the main module, and the overall safety of the user.
All right, so let's start with the technical drawing. So this is an expanded view of the side. So this is pretty much how the different parts are going to be stacked up each other, and we're gonna have some example wiring, a way we can wire it. And there's pretty much we're gonna have battery on top. Then we're gonna have the ceiling where that's gonna hold it, and then gonna put breadboard underneath that, and then gonna have another one with a little bit of space in between, so we can get some airflow in there, so we can keep everything nice cool. And have the Arduino on the bottom. We're gonna have wires going throughout the entire system. That's why I left the whole right side with extra space for it. Of course, the top is to allow air from the top to go into the bottom by the battery, so the battery stays nice and crispy and cool. And we can move on to the next technical drawing part. It's really where you get the sizes and how everything gonna be layered, or what the layer you're gonna be layered on. It's gonna be about 6 inches long by 3.5 inches tall. So it's gonna be a thick boy, and it's of course that's just pretty much what it is right now. It's pretty much the same as top with measurement. We can see each layer we got 1 inch, 1.5 inch, 0.75, everything. So top view, it's pretty much gonna be simple. It's just a normal cover to protect it from the element and all that. It's gonna be great. 4 inches by 6. Uh, Other side, we're gonna have this little part for design that needed to reroute the power. But this is where USB. So this is where we can plug things in to program the Arduino, and when we're testing it. So remember, this is not drawn to scale, so it's probably going to be actually a lot wider, bigger than this. These are the glasses going to go in. So you see, we're going to have two sensors, one that go into each lens with a wire going to the side, and it's going to go through the glasses frames into the wire down to the doornail. So physical makeup, since we haven't been together and we haven't actually started making it, we don't have a physical mock-up yet, so we don't have a physical prototype. But that's why I decided to draw a picture of how it would look on a person, so people can start to see how um just how it looks on them, how it will fit on person. I mean, with this, you're improving that you can wear our devices still look pretty classy. Surveys, we're still getting in results, and we have multiple interviews scheduled with blind individual. Of course, social distancing. We're make sure we take all the precautions very seriously. So right now we don't have many results to show. We're still receiving them, and we're hopefully going to have a useful information to further adjust the designs and adjust and address more problems.
And then for the design concepts, mainly what we got through the design concepts was the overall time we want to create was the efficient and safe product for the users and the consumers, so they get a good experience with it. And so for that, we had to get multiple inputs from different users and from our stakeholders. And so we had to use multiple sketches to fully understand what everyone was proposing, so we could try to get just the best possible product with all the great pieces that we needed.
And for STEM principles, we'll start out with science, or main thing that will affect science with our project is going to be humidity, because humidity can affect how well our ultrasonic sensor will work. Moving on to technology, the main piece of technology we'll need is Arduino board, wires to connect everything, an ultrasonic sensor, battery pack, and piezo buzzer. And for engineering and technology, need engineering. The main discipline that will affect our project is electrical engineering, since we need to have proper wiring to ensure our product is safe for someone to wear. And for math, we'll have a formula to measure the distance between a foreign object and the user. And for our overview, it's to ensure that our ideas weren't just guesswork. We thought out each idea and came up with problems with each idea to make sure that our ideas were good.
So some advantages and disadvantages that we ran into was that on the good side, it could help the blind navigate through changing environments. So if something's coming at them, they'd be able to move out the way easier. So they'd get a uh, response time sooner than if they were moving with a walking cane. The weight, it's supposed to be distributed between the glasses and the fanny pack so that it doesn't put too much weight on either the head, the arm, or their waist. And the battery life, since it's running a Arduino and sensor, the average time for it to run is about 6 to 8. Now, compared to the pros, the cons seem more like inconveniences, since to be fully effective, it does have to be combined with a walking cane. So if something's coming at you, it'll alert, and then you use the walking cane to make sure you like 100% don't hit it. Uh, the product, as many productions do, it'll cause some pollution with the handling of metals, the burning of fuels in order to power their machines to press it, and some sort of extra equipment has to be worn apart from the glasses itself. So the laws that affect our product, we originally looked for laws that would affect the blind in particular to see if there was any certain rules or safety regulations that you have to follow in order to get the product produced. But instead, we found out that mainly it just has to follow normal health and safety regulations. It doesn't focus or make the blind population an outlier. The main point of the laws is that we have to get rid of any product defects or risks like the exposing of wires, especially on the head. And we have to make sure we check it and make sure that it is 100% safe.
And for the product life cycle, for the acquiring of raw materials and the producing of the devices itself, we will leave to other companies as they'll be the main ones focusing on that. And so we'll really start to come in when we collect the pieces, which would be at the box at the bottom right. And that's when we get all the devices, the different pieces, and we really put the product together and make it what it is. And then we will send it out to our customers and consumers, which will then hopefully allow them to have a better quality of life standard as they can experience better social situations in public spaces. And then if there's any malfunctioning products or any that are unused, for using the devices, we can easily use the plastic again. We can take the devices, put them in other machines that may use them, and we can also just rebuild any that needs to be made. So if it's malfunctioning, we can just replace one piece and then send it out again.
As to why we think this product is viable, it'll help improve the blind when navigating through difficult environments. Simplistic goals and requirements are easily achievable, and our overall intention when making this product is to assist the blind in avoiding any danger. For our three main limitations, number one is technology. So we can't get all of the technology that we need currently if we were to make this thing fully functional, fully finished, and what we imagined. So cameras give a lot more detail, but it'd be a lot harder to get, which is why our next limitation, budget, comes in. Getting high quality cameras and sensors, all of those can wind up having to cost a lot. So having not enough money can really hinder our ability. And time, our time isn't too bad for what we shortened our product out to be. It it does put some cap on the amount of work we're able to get done though. And overall, a quick summary is that advantages, in my opinion, they greatly outweigh the disadvantages, which can almost be seen as inconveniences. And there's no law that could directly impact the blind. Our goals are simplistic, they're easy to achieve, and the limitations won't affect the product that we're able to create.